Hi everyone, welcome to this tutorial on basic VLSI design. I am Goura and today we are going to break down area capacitance of layers step by step. So let's get started. Area capacitance of layers. For any layer, if you know the thickness of dielectric, in this case silicon dioxide, we can calculate the area capacitance. Area capacitance is given by this equation, that is C equal to epsilon naught epsilon inch A by D, where D is the thickness of silicon dioxide, A is the area of plates, epsilon inch is the relative permittivity of silicon dioxide, that is 4, epsilon naught is the permittivity of free space, that is 8.85 into 10 to the power minus 14 farad per centimeter. Actually, we want to calculate the capacitance in picofarad per micrometer square. For that, we put D in centimeter and epsilon naught in farads per centimeter. This table shows the area capacitance of MOS circuit. The capacitance from gate to channel is 4 into 10 to the power minus 4 picofarad per micrometer square for 5 micrometer technology, 8 into 10 to the power minus 4 picofarad per micrometer square for 2 micrometer technology, 16 into 10 to the power minus 4 for 1.2 micrometer technology. Similarly, the capacitance for diffusion or active area 1 into 10 to the power minus 4 picofarad per micrometer square for 5 micrometer technology, 1.75 into 10 to the power minus 4 picofarad per micrometer square for 2 micrometer technology, 3.75 into 10 to the power minus 4 picofarad per micrometer square for 1.2 micrometer technology. Similarly, the capacitance from polysilicon to substrate, metal 1 to substrate, metal 2 to substrate, metal 2 to metal 1, metal 2 to polysilicon is given. This table also shows the relative value of capacitance inside the parenthesis. The relative value of capacitance from gate to channel is 1 for 5 micrometer, 2 micrometer and 1.2 micrometer technology. Similarly, the relative value of diffusion capacitance is 0.25 for 5 micrometer technology, 0.22 for 2 micrometer technology, 0.23 for 1.2 micrometer technology. Similarly, the relative value of capacitance from polysilicon to substrate, metal 1 to substrate, metal 2 to substrate, metal 2 to metal 1, metal 2 to polysilicon is given in this table. Standard unit of capacitance. The standard unit of capacitance is denoted by square Cg. It is defined the gate to channel capacitance of a MOS transistor having W is equal to L. That is called standard or feature size. The standard value of square Cg is area per standard square multiplied by area capacitance. The area capacitance is given in the table. For example, if we take 5 micrometer technology, the area per standard square will be 5 micrometer multiplied by 5 micrometer, that is 25 micrometer square. And the capacitance value from the table, that is 4 into 10 to the power minus 4 picofarad per micrometer square. So the standard value of Cg is 25 micrometer square multiplied by 4 into 10 to the power minus 4 picofarad per micrometer square, resultant that 0.01 picofarad. Similarly, for 2 micrometer technology, the area per standard square is 4 micrometer square. Gate capacitance from the table is 8 into 10 to the power minus 4 picofarad per micrometer square. Thus, the standard value becomes 0.0032 picofarad. And similarly, for 1.2 micrometer technology, the area per standard square is 1.44 micrometer square. Gate capacitance from the table is 16 into 10 to the power minus 4 picofarad per micrometer square. Thus, the standard value of square Cg becomes 0.0023 picofarad. Now, if you want to calculate the capacitance for the substrate, the capacitance of the substrate is denoted by relative area multiplied with relative C value, where relative area is denoted by the area of substrate divided by the area of feature size. For this substrate, the area is 20 lambda by 3 lambda. the area of feature size is 2 lambda by 2 lambda. So the relative area becomes 15. Now if we think this substrate is metal 1, so the capacitance for metal 1 will be the relative area of this substrate multiplied by the relative C value of metal 1 from the table, which is 15 multiplied by 0.075 square Cg, resulted that 1.125 square Cg. It means that the metal has the capacitance to subtrate 1.125 times that of the feature size square gate area. If you consider this substrate is polysilicon, then the capacitance of the substrate will be 15 into 0.1 square Cg from the table, so it becomes 1.5 square Cg. Now if you consider the substrate is n-type diffusion, then the capacitance of the substrate will be 15 into 0.25 square Cg from the table, resulted that 3.75 square Cg. Now we want to calculate the capacitance for multi-layer substrate. At first we are going to calculate the relative area of metal 1. The length of metal 1 is 100 lambda and width is 3 lambda. So the relative area of metal 1 is 100 lambda multiplied by 3 lambda by 4 lambda square, that is 75. So the capacitance of metal Cm is 75 into 0.075 from the table, that is 5.625 square Cg. Now we want to calculate the relative area for polysilicon. For this square box, the area of polysilicon is 4 lambda multiplied by 4 lambda. But for this portion, the length of polysilicon is 1 lambda plus 2 lambda, which is 3 lambda, width is 2 lambda. So the area for this region is 3 lambda multiplied by 2 lambda. So the total area of polysilicon is 4 lambda multiplied by 4 lambda plus 3 lambda multiplied by 2 lambda, that is 22 lambda square. And the capacitance for polysilicon is Cp, which is 22 by 4 multiplied by 0.1 from the table, which is 0.55 square Cg. For the transistor, this means this gate capacitance is 1 square Cg. So the total capacitance, metal capacitance plus polysilicon capacitance plus gate capacitance, which is 7.20 square Cg.